Under what conditions B1 and B2 does Ax is equal to B have a solution? Matrix A is given. Find the two vectors in the null space of A and the complete solution to Ax is equal to B. So here the three categories been asked. So we'll solve one by one. So first we go for finding the conditions on B1 and B2 where Ax is equal to B, it will be having a solution. So here now consider the augmented matrix 1, 2, 0, 3, 2, 4, 0, 7, vertical line B1, B2. So reduce it to the echelon form by applying the transformation function. So in order to have the zeros in the bottom rows, so here we will go for applying certain transformation function. So here I'll be applying R2 minus 2R1. So if you apply that, so here the above matrix, it will be reducing to 1, 2, 0, 3, B1, and here it will be having the values like 0, 0, 0, 1 and vertical line B2 minus 2B1. So further, even if you apply any other transformation, it will not be reducing to 0. So here, if you observe this, so here you can see that pivot is present in the first column and in the fourth column. So here, if you consider this as x1, x2, x3, x4, so wherever pivots are present, excluding that, here you can make the statement that x2 and x3 are free variables. So here, free variables from this matrix is x2 and x3, whereas x1 and x4 they are considered as the dependent variable. So now from this, if you separate the augmented matrix 1, 2, 0, 3 and 0, 0, 0, 1 multiplied with x1, x2, x3, x4, which is equal to b1, b2 minus 2b1. So here we'll be having, in order to have a solution, so simplify this, x1 plus 2x2 plus 3x4 is equal to b1, and here x4 is equal to b2 minus 2b1. So since x2 and x3 are free variables, so here I'll put x4 as 0. Now to have the solution, so here we are going to find the conditions. So here if you put x1, x3 and x2 are free variables, right? x3 and x2 are free variables. So x3 and x2 are free variables. So here I'll be writing this as put. So here I'll write x1. I have not written the echelon form of this 1, 2, 0, 0, 3. And one more operation I'll be performing here, otherwise I'll not get the solution, it will be wrong. Just wait a minute. So here just apply one more operation for this. So obviously x2 and x3 are free variables, but let me apply one more operation like r1 minus 3r2. So otherwise it will be difficult to write a solution. So here when we apply r1 minus 3r2, then the first row element, it will be 1, 2, 0, 0, and this will be 7b1 minus 3b2, and here 0, 0, 0, 1, this will be equal to b2 minus 2b1. So here pivots are present in the first and the fourth column, and x2 and x3 are, as I told, they are the free variables. So here in order to have the solution, in order to have the condition, so here let us consider, my God, what's happening? So here we can have this. So in order to have the condition, so here we can write b1 belongs to R, and B2 minus 2B1, it must be equal to 0, which implies that B2 is equal to 2B1. So these are the conditions on which for which the solution for Ax is equal to B exists. And now considering this reduced form, so here we can have x1, what I'll write, 12000001 multiplied with x1, x2, x3, x4, which is equal to 7b1 minus 3b2, b2 minus 2b1. So here, if you simplify and write the expression, so here we get x1 plus 2x2 is equal to 7b1 minus 3b2, and x4 is equal to b2 minus 2b1. So now here if we have x1 plus 2x2, if it is equal to 0, it implies that x1 is equal to minus 2x2. So having this, so you're putting x2 is equal to 0 here since it is a free variable. So for free variable, you can set any value as any value either 0 or 1. So here we'll be getting x1 is equal to 7b1 minus 3b2, and x4 it is equal to b2 minus 2b1. So here we can write the solution as 7b1 minus 3b2 in the place of x1, and x2 is b2 minus 2b1. So this is the particular solution. And for null space, here we'll be having, so x1 is equal to minus 2x2, and x3 it can take any value either 0 or 1. So here we can have the values like 0 0, and x1 it is equal to minus 2 and 0. So here the total solution for this is 7b1 minus 3b2, 0 0, b2 minus 2b1 plus x2 of minus 2 1 0 0 plus x3 of 0 0 1 0. So now we go to the next problem. So find the special solution to ux is equal to 0. That is ux, it is given as 1 2 3 4 0 0 1 2 0 0 0 0, and here x1 x2 x3 x4, which is equal to 3 zeros. So for this, let us find the special solution. When you ask special solution, so it is nothing but it is a null space. That is, for equating to 0, you have to get the equation. So here already it is in the reduced form. So here we can see that the one zero vector is present. Excluding that, the rank of the matrix U is 2, and pivot is present here and at this point. So here you can consider x2 and x4 as free variables. So here x2 and x4 are free variables, and x1 and x3, they are the dependent variables. So now if you simplify the equation, so here we'll be getting the equation like x1 plus 2x2 plus 3x3 plus 4x4 is equal to 0. And from the second row, here we have x3 plus 2x4 is equal to 0. 2x4 is equal to 0, and which implies that x3 is equal to minus 2 times of x4. And as we know, x2 and x4 are free variables. Here we have identified x2 and x4 as free variables. Having this in our mind, so here we'll go for writing the special solution. So now I'll make two columns for writing the solution. So once I'll put x2 is equal to 0 and x4 is equal to 1 in the equations. And for the second time, I'll put x2 is equal to 1 and x4 is equal to 0. So when x2 is equal to 0 and x4 is equal to 1, So the equation 1, so whatever we have x1 plus 2x2 plus 3x3 plus 4x4 is equal to 0. So that will be reduced to, so x1 plus 2x2. So here 2 into 0 is 0 plus 3. But x3 is minus 2x4. I'll just put substitute here plus 4x4. It will be equal to 0. And here since x4 is equal to 1, so substitute that value plus 3 into minus 2 plus 4 is equal to 0. So which will be giving the answer of x1 as 2x4 in the one. So x1 is equal to, here I'll be getting minus 6 plus 4 is minus 2, that is x1 is equal to 2. And with x1 is equal to 2 and x3 becomes what? So x3 we have minus 2x4. So when you substitute x4 as 1, it will be resulting in minus 2. So here one solution we can write as solution 1. It is alpha, any constant. So here x1 is 2 and x2 we have assumed as 0 and x3 it is obtained as minus 2 and x4 we have assumed as 1. So this is one solution. So similarly for the same equations, so change the variable values x2 as 1 and x4 as 0. So with that, so here we'll be getting, so if you use these values in the equations given here, so whatever the equations you are going to see, so if you substitute x2 and x4 with these values 1 and 0, I'll be writing the direct values here. x1, it will be resulting in minus 2 and x3 which is equal to minus 2x4, that is nothing but 0. So now we can have the solution, second solution as solution 2, which can be written as beta. This is some constant. So x1 is minus 2, x2 we have assumed as 1 and x3 is obtained as 0 and x4 we have assumed as 0. So this is the solution. So here combining these special solution, we can write the total solution, total special solution for x1, x2, x3, x4 as alpha 2 0 minus 2 1 plus beta minus 2 1 0 0. So this is the answer for this. So another type of problem I'll just show, last problem. So similar problems I'll be giving to you. So solve those. So these are all exercise problem from the Gilbert Strang. So you need to solve this. So what are the special solutions to Rx is equal to 0 and R transpose Y is equal to 0 for R is equal to 1023 and 0145 0 0 0. So this matrix is given. So given this, we are asked to calculate the special solutions for this. So here I'll just go with the method. I'll do it fast. So here 1023 0145 000. So since 4 columns, so we'll be having 4 variables x1, x2, x3, x4, which is equal to, so already it is given as 0. So here no need to bother about other values like b1, b2, b3. So directly equal to 0. So here already it is in the reduced form. So identify the pivots. Pivot is present in the first and second column. So here x1, x2 they are dependent variables, whereas x3 and x4 are free variables. So here identify the free variables. So here x3 and x4 are free variables. So having this, once again whatever we have done previously, so here make you write the equations first. So here we'll be getting x1 plus 2x3 plus 3x4 is equal to 0. This is one equation. And the second equation x2 plus 4x3 plus 5x4 is equal to 0. This is the second equation. So now having this, so you can consider the special variables x3 and x4. Once you set this value as 0 and 1, and for a second time make x3 as 1 and x4 as 0 in the equations 1 and 2. And if you have that, if you substitute, so here for the first column we'll be getting x1 as minus 3 and x2 as minus 5. And in the second column, so here we'll be having x1 as minus 2 and x2 it will be resulting in minus 4. So identifying these values, so now you can write the solution 1 is equal to 1, C1 multiplied with x1 is minus 3, x2 is minus 5, as they are a dependent variable. X3 is assumed as 0 and x4 as 1. And solution 2, so here this is C2 with the values x1 it is minus 2, x2 is minus 4, x3 it is assumed as 1 and x4 is 0. So now you can write the complete total special solution as, so here x1, x2, x3, x4 is equal to C1 minus 3 minus 5 0 1 plus C2 minus 2 minus 4 1 0. So this is the special solution for Rx is equal to 0. And similarly, you can have R transpose Y. So here R transpose Y in the sense, here I'll write the equation for R transpose Y. Just select the pen here. R transpose Y, it should be equal to 0. So here, whatever the column elements are there, that will be shifted to the rows, and row elements will be shifted to the column. So here 1 0 2 3 it will be here, and 1 0 0 it will shift to the row. So here having this, so we can write here, R transpose Y is equal to 0 as 1 0 0. See, I'll write the elements 1 0 2 3 0 1 4 5, and all are 0 here. So now this y, it will be only 3 elements, y1 y2 y3. It is equal to, so since 4 rows are there, so it will be equal to 0. So now if you write the equation, so y1 will be 0, y2 will be 0, and next we'll be having 2y1 plus 4y2 is equal to 0, and then 3y1 plus 5y2 is equal to 0. So now in this you can identify the pivot. So here y1 is okay, y1 y2 y3, y2 and y3 they are free variables. So y1 already it is 0, y2 is also 0, and y3 it is it can take the value like here I'll take y3 as a 1. So actually I had to reduce it to the echelon form. So here the solution y1, y2, y3. So y1 is 0, y2 is 0, and y3 you can take that as 1. So this is the solution for this. So similarly, you can have so many problems. I'll be posting all these problems solutions to you. You just work on this. So with this, in the next, we'll move on to the next topic, orthogonality. Thank you. You can leave the meeting and join for the next class.